Hello, everybody, and welcome to the South Florida Power BI user group. My name is Adriano, your host, and thank you for making the time to be here with us on our first 2023 presentation, which is also our first simulcast presentation where we are here transmitting live from the Nova Southeastern University. So we have attendees on premise as well as online. So welcome everybody. And if you're online, let me know. Can you hear us well? Can you see the images? And also let us know where are you located. So take a minute, drop a comment, let us know where you are located at. And we have here, let's take a look. We have Marco. Hey, Marco. Thanks for joining us. Appreciate it. And let us know where you're located as well. Now, today presentation, we have Unleashing Power BI with AutoML. And also, I know AutoML is traditionally a premium offering, but Hector Villafuerte today is going to show us how to use that feature without the use of premium. So it's going to be very exciting here, so you can maximize the usage of Power BI with your license, and you can experience, and then you can enhance and include here Power BI Premium if you so desire afterwards. All right, we have, thank you, Marco. Let us know, right down the street, Marco, from Cooper City. Good, and thanks for letting us know that you can hear well. All right. Now, without further ado, we are going to have here Hector. Welcome.
Hector. Hey, welcome, everybody. My name is Hector Villafuerte, and I'll be the presenter for this session, Automate Machine Learning, AutoML in Power BI.
Great, Hector. Let us know where you're located at, and can you give us just a little bit about the presentation? I know that you will engage and tell more about it during the presentation, but just like a quick glimpse.
Mm-hmm. Yes, I'm located in South Florida, and I've been working with Power BI since the preview. Before Power BI had enough capability to be on production, is many years ago. I remember at the time we were evaluating Power BI, Tableau, and Cognos, and we're still waiting. It was waiting of the previous features of Power BI, and Power BI started to deliver new features in monthly basis until we decide to go all with Power BI. So I'll tell you, I've been working with Power BI and Microsoft technologies for many years now. I have a specialization in machine learning and some Microsoft certifications. You can reach me at my email below in the presentation.
All right, Hector, we are all set.
Perfect.
You ready?
Perfect.
All right, let's get to know about Hector, and let's get this started here, folks. Unleashing Power BI with AutoML. Hector, it's all you.
All right. Yeah, as I told you, I'm located in South Florida. I'm a software professional, and I was working many years with Power BI. And today's presentation is going to be about AutoML and Power BI. This is the agenda of today. We're going to talk about AutoML, and then we're going to do a demo. We're going to build a machine learning model based on a small data set. We're going to create a data flow with input data. We're going to create and train a machine learning model with that data set. We're going to review that model, and we're going to apply the model for another data flow entity. Okay. Then we're going to using a score output from the model in a Power BI report. All right, what's machine learning? Machine learning is going to allow us to predict or get answers from our data, right? But it's going to build a model and it's going to provide results or predict labels. In this case, like you can see, the input data is going to be a data set or with a lot of fields, a lot of features, information, plus a label in case we want to do we want to predict an answer. And based on the multiple techniques and algorithms, our our model is going to be built, and at the end we're going to be able to predict this answer with a level of probability, right? There is two kind of machine learning, uh, supervised learning and unsupervised learning. In supervised learning, we're going to try to guess or predict a, a, a label or a value. If we try to predict a number, it's going to be a regression, a machine learning with regression algorithms. If we are going to predict a label with two or more categories, it's going to be a classification. If there is only two categories, it's going to be a binary classification. More than two is going to be a multi-class classification. We also have the unsupervised machine learning algorithms. That is, among those are cluster analysis, density estimation, and dimension reduction. These are out of the scope of this presentation and are not part of the AutoML in Power BI functionality. Okay, in Power BI AutoML, we only can do a supervised learning with regression or classification. Okay, this is simple examples of regression. Let's say we want to predict a value, the return, and compare versus the real return. And we're going to have this kind of correlation between these two. The ones that we use for the model, our model we're able to predict, and we're going to compare with the real data that we have, the historical data. And we have another sample, a use case of trading where we try to guess if we're going to buy or sell. If we have only these two options, it's going to be a binary classification, right? Based on historical data, we want to predict if we're going to buy or we're going to sell a stock, right? That will be a binary classification. Okay, in this slide, you can see at the top all steps in a traditional machine learning workflow, since the data acquisition to the predictions. Okay, in the machine learning workflow, we have many steps. There is many advanced techniques, algorithms, data preparation, feature engineering, model selection, model training, hyperparameter tuning, and iterative approximation to get the best model, and finally to get the right model that get the best predictions. In this case, what we're trying to achieve with AutoML is to try to simplify all these steps. Okay, going from the data acquisition to the prediction, and try to simplify all these steps. You're going to see we don't eliminate these steps. These steps are still executed by the by Power BI, and it needs some interactivity, some interaction. But the simplification is very high. There is some step that needs very specialized technical knowledge that with AutoML is not needed. Okay, AutoML is supported by multiple providers. There is Google AutoML, Amazon SageMaker. There is some libraries, AutoKeras and AutoSKlearn that support AutoML. In the Microsoft world, there is Azure Databricks and Azure Machine Learning also that support AutoML. Okay, and Power BI Premium supports AutoML, and Power BI Premium per user also support AutoML, even though the Power BI free license doesn't support it, and Power BI Pro, it's a paid license, doesn't support AutoML. Okay, so you have to have the premium capacity either than per user, or you can buy it by server. The premium capacity gives you not only AutoML, it gives you a lot of features that you can see here. A lot of advantages doing data flows, data mart creation. There is also allows you to do some paginating reports in here. And you can see there is some, if you buy by the server, you don't need to buy by user, right? You either buying by the user, or if you have many users, is most cost effective to buy it by the server. Then you don't need a license by user. Okay, and there is multiple capabilities and multiple features that are available with Power BI Premium. Okay, and this is the cost. The Power BI Pro that doesn't support AutoML is about $10. The Power BI Premium per user that gives you AutoML and premium capabilities is $20 per month per user, even though this is a minimum capacity, right? And the same thing, if you buy the capacity per server hosted in the cloud, is going to be about $5,000 per month. And this is also, again, the minimum capacity. Okay, so like Adriano mentioned, there is another way. If we don't want to commit this payment per month, or we don't want to commit a payment per user, what we can do is use the exact capacity in Azure using the Power BI embedded services. Okay, in the Power BI embedded services, we have more flexibility. It gives us the same premium capacity, but we have to create our service in Azure. In this case, the cost is going to be by the hour. If we use this capacity for the minimum plan, is going to cost you $1 per hour. Okay, and we can even escalate, and we can use a high capacity if we need to execute a big model or more data, and it goes $32 per hour. And we can pause the service, and we can destroy the service if we no longer need it. We don't have this capability if we go to this licensing structure, right? We have to pay $5,000 per month. That's it. We don't even if we don't use it, and the same thing per user, right? Okay, and this is the way that we're going to use during this demo. Okay, so let's go right away. Let me just confirm if you can see my screen, my Power BI screen.
Yeah, they're looking at the
okay,
Workspace.
Perfect. Right, so I have this Power BI service on the cloud. Okay, and let me open here some settings and go into the admin portal if I am Power BI administrator. Or here I'm going to show you some yes.
All right, just one quick second here. I'd like to remember everyone, if you have any questions during the presentation, use the live chat to enter your questions. After the presentations, use the comments, and we will follow up with the presenter on the questions. All right, thank you, Hector.
Sure, yeah. So any question, yeah, just give it to the chat and I'll answer right away. All right. So I have this I in the admin portal, and we are in the capacity settings, and we have Power BI Premium. I don't have that. I'm not paying for that. I'm using the Azure option, the Power BI Embedded, that gives us same capabilities. And I have a couple of instances there, but let me create one from the scratch. So I'm going to do everything uh, from from the scratch, right? Let me create. Let me go here and okay. Okay, let me create a resource group. Okay, I'm going to create everything here. Okay, let me call this um, Power BI demo 99. Let me see. Okay, be able to create this. Okay, perfect. Okay, and over here, let me see if I could create a Power BI embedded. If you don't see it, and again, this Azure, if you're working at a company, you might not be able to have access to the Azure. The creation of services is only available for an Azure administrator, tenant administrator. Okay, but it's very simple. We just have to create the service in the resource group that we want. In this case, it's Power BI Demo 99. We're going to enter the name of the service. Call it Power BI Demo 99 also. Power BI Demo 99. Let's leave it as a default everything, and I'm using the minimum capacity, but if I want to have a higher capacity, we also can pick any of those. Okay, great. And it's going to take just few seconds. Let's give it time. So it's creating the resource in Azure. Okay, and it did it. Okay, let's go to the resource. Okay, and as I told you, you have the possibility right now is the Power BI, this service is running. Okay, you can pause it. Okay, and when you pause it, you don't pay for that. Okay, you only pay when it's running. And also, you can give permission to one user. So it's going to be able to give this capacity access to workspaces in the Power BI service. All right. Okay, so now let's go to Power BI, and you see immediately it refreshes and it detect that there is a new instance of Power BI embedded in Azure. All right, so now what I'm going to do, I'm going to create a workspace. Let's call it the same, BI 99. Just scroll down, and there is an advanced option here. In this advanced option, we have a option to select Pro, where we want to how we want to use this workspace. Pro, Premium per user, or embedded. We want to use the embedded service, right? We're going to pick this one for VI Demo 99. All right. So the workspace has created, and if you see there is a little diamond here, that means that this workspace have premium features, right? So now I have the capacity to create data flows, and this is the this is the thing that I'm going to do. And here we're going to create a new data flow. We're going to define a new table with my data, right? And my data is in a CSV text, is in the cloud. Let me just copy here the URL. Okay, I have the copy here. Perfect. All right. Okay, so the information is here. It looks fine. Let me see. Let's transform the data. And now in the data flow, we're going to Power Query on the cloud. Now we can see all the information here. Here we have the possibility to use Power Query and do transformations if we need it, right? If there is some fields that are not automatically detected or the type is wrong, here is we can correct that. Okay, everything looks fine. Like you see, let me talk a little bit about this dataset. What this dataset is a log of a history of users interacting with a website. Okay, there is different metrics, duration, which page, which product they browse in the internet, what was the duration, bounce rates, exit rates, page value, which day, which month, which operating system they use, which browser they use, traffic type, region, visitors, and revenue. Okay, and all we call in machine learning language, we call features to all these fields or attributes. And the outcome, the field that we are interested in predict is the revenue. So based on all these features, we want to predict is this user is going to buy, is going to produce revenue, is going to do the purchase, false, is going to be false or true, right? There is a bunch of false. Okay, there is some few that are true, right? There is true values also. Okay, so I proceed to save and close. I'm going to call this um, purchase um, or purchase data. Okay. All right. Let's refresh this just in case. Okay, I could verify this table has all these fields and the revenue with the column that I'm interested. At the same time, now I'm here. I'm going to go ahead and also create another table. Okay, this table is the one that I'm going to use at the very end once my model is ready. Okay, same thing. I call it new data. Okay, let me show you the difference. Is exactly the same structure of the data set, the previous data set, the same attributes, features, except there is no revenue here. There is no revenue field. Why? Because this is going to simulate new data that the model is going to predict, right? It's going to, based on this data, the data is going to predict if we have revenue or not. Okay. Okay. I'm gonna rephrase this. Okay, so we have two data sets. We're going to use this data that has the revenue flag to train the model, and then we're going to use this. We're going to apply the model in this new data table. All right. So next, what we have to do is go to this tab, and here is going to show all the steps that Power BI is going to do. We're going to drive also, or Power BI is going to drive us to complete all this workflow, right? Okay, let's start it. Okay, number one, we're going to select which table we're going to work with. Okay, we're going to select this intention data, right? And what is the outcome column? The column we want to predict. That column is the revenue column. This one. Okay, we click next. Okay, now first facility. It gives us immediately what we are looking for and what we going to choose as a model. It's going to do a binary prediction. Why binary? Because it's going to predict only two values, or between true and false, right? Um, we have the possibility to override this in case there is something that we want to do differently. Regression is not possible, is not numeric, so it's disabled, but there is a general classification that is used if we have more than two values, right? Three or more values. So, binary prediction is okay. So next we're going to choose the target outcome. We have two values. Which value we are interested in? In this case, we are interested in the true value. We're interested in the customers that are doing purchases in our website. Okay. Next, we're going to um, type the text that is going to show us the label. Let's call it purchase. And here, let's call it no purchase. Okay, let's do next. Okay, in this screen, what Power BI did is automatically is going to give us and select all the fields, all the attributes or features that we should include for our training, right? There is some fields that are not selected, and there is the reason in the between parentheses. It says low correlation with revenue. Okay, there is low correlation with revenue with a lot of fields in here, and there is only select the fields that have high correlation with the revenue. Of course, the revenue is disabled. It's the one that we're going to try to predict, right? Many times we can have even, for example, if we have the client ID, it's going to be low correlation, right? If we have a client ID or even a phone number, the phone number could be it's going to produce a low correlation with the decision of purchase or not. But sometimes maybe we cannot use the phone number, but we can use the region code, the code, the first three digits. That could be a correlation with for a model. So in case that we need to do something different than Power BI detected, we can override, right? We can include or exclude things that we see that doesn't make sense, right? That is depending on your business knowledge of the model, you're going to override these values if this is not correct. Okay, we're going to leave it as default in here. We're going to click next. Okay, in here we're going to type a name, purchase model. Okay, and here there is a training time slicer. Okay, the maximum time is going to be 6 hours, or the 360 minutes. All right. Of course, for this presentation, we're going to do the minimum. Okay, we're going to do 5 minutes so we can show the results. Okay, and the other thing is, of course, the more time to give to Power BI, it's going to be the better, right? Power BI is, behind the scenes is going to start to iterate and to try multiple different algorithms, and in each algorithm is going to try also to try different parameters, different hyperparameters, to get the best results, right? If we want the best, we have to give them more time, right? But for purpose of this demo, we're going to limit to 5 minutes only, right? And it says what happened next. Um, in this note, is explaining that it's going to split our, our data in two pieces. One, one piece is going to be the training data, is going to be 80% of the records, and the other one is going to be 20% of the records is going to be used for the evaluation. And for this evaluation is going to produce some metrics that is going to be the output in a nice report that Power BI is going to produce. Okay, so I'm going to click here, Save and Train. Let's see. Uh, let's delete this from the cache. Okay, and you see, okay, let's refresh this. It creates two tables, one for training with 80% of the data and one for the testing with 20% of the data. Okay. All right. So right now, this is the purchase model. It says ready status, but it's not ready. Let me see. I don't think it's going to. It's still running. You see a progress. This is still running. So we have to give it some time, like 5 minutes, and come back there. All right. Once it finishes, this is going to show this enable some buttons for the report enable. Right now they are disabled because it didn't finish the training, still doing it. Right. In the meantime, we're going to go back to the slides to explain the output that is going to produce. All right, the metrics that we're going to get for this classification, this binary classification, is something called confusion metrics. All right. Just be aware that all these steps in the machine learning workflow, that is for the evaluation, the model training, the splitting, all was done automatically for Power BI, and that reduces the expertise. But at the end, we need to know how to read the information that Power BI is going to deliver, and this is the piece that Power BI is not give us. It cannot help us more, right? It gives us this information, and you have to interpret this, right? So how we read this? This piece of information is very important. It's called the confusion matrix, and the confusion matrix is a summary of all the all the predicted values versus the actual values. Okay, in one side we have this actual value that in our case was a purchase, users that did a purchase in our website, and our machine learning model might be able to predict that it really did a purchase. So this is going to be a true positive. Okay, if the machine learning model did a mistake, then it's going to be a false negative in this case. In case that the user didn't make a purchase, right? No purchase, but the predicted model, the predicted value was a positive, it's going to be a false positive. If our model predicted predicted correctly that this user didn't make a purchase, then it's going to be a true negative. So they will have correctly in green true positives and true negatives, and in red we have false positives and false negatives. Based on these values, we have all these metrics that Power BI also is going to give us, right? The classic one is the accuracy. The accuracy, we have all correct values, true positive and true negatives, divided by all values, all number of records. And this is going to give us a percentage, right? We have sensitivity, true positives, divided by all positives. Precision, true positive, divided by predicted positives, and specificity, true negatives, divided by all negatives. Okay, so we need to learn how to interpret these values, right? Because this is the end product that Power BI is going to allow us to work with our business. Okay, and here I have a question. When we say, is this accuracy ranking correct? The accuracy go from 0 to 100 or 0 to 1, right? Being 100 a perfect prediction, 0.9 excellent prediction, 0.8 a good prediction, 0.7 or 70% mediocre prediction, 60% pure prediction, and 50% a random prediction, right? And if you get in your model something less than 50%, is something wrong, right? It might be better if you flip around, and then if you get 40% the wrong prediction, then you might be flip it and do the negative, right? 1 minus your predicted value. So is this correct? Is this accuracy is the most important thing? How we compare a model in one case versus a model in another case? Can I say that the machine learning model that I did for one client that produces 80% is better than another one that I did for another client in another industry that produces 70%? Not really. Okay, this is wrong. The accuracy is specific to the use case, right? And the accuracy of 90% of accuracy, as a sample, for a credit card fraud detector model is really bad, because in a credit card report, in a credit card fraud detector, we want to predict as much as we can. As it might be ended up with 97 or 98%, right? To be able to detect all the fraudulent transactions. Instead, an accuracy of 60% in a stock trading model, that's excellent. There is nothing that goes as high as that, right? 60%, meaning that from 10 trades, we're going to have 4 losses and 6 winners, right? So it's going to be profitable.
Press F5, please. F5. For your, what I want to do is maximize that, because I can see the other slides on the left.
Oh, okay, gotcha.
Presentation.
Right. Okay, and here is the same, again, the screen, one piece of the screen of Power BI. And also, again, we need to know how to read and how to use this information. The problem is not, you don't end up having the report, Power BI report, and what are going to do with that, right? It doesn't end there. A business analyst or a data scientist has to tune this information. And Power BI has a very interactive way to do it. And you're going to see it later on. They have a slicer where you can, when you can play with the recall versus the precision. These are two opposite, or there is a trade-off between these two measures. Okay, if you increase the recall, you're going to decrease the precision, and vice versa. The you have to think about your use case in here. What is your goal? What is going to affect you the most, right? In a again in a fraudulent transaction detector, when positive class is fraud, right? What you want is to minimize the false positives. Okay, I want to minimize the false positives. Meaning that I want to capture as much fraudulent transactions as I can, right? Even though there might be some false negatives on its way, right? If you think about it, if you don't care if your bank can call you and to ask you about a legitimate transaction, right? And you can answer, okay, this is a legitimate transaction, no problem. But you really want to be sure that you want the bank to capture all the real fraudulent transactions, right? So the other way is the opposite thinking is in this scenario in the spam filter. When the positive class is spam, what you want is to minimize the false negatives, right? You want to minimize the false negatives, meaning that if you really want to, you don't want to lose a very important email from your client or from your boss, and it is going to be classified as spam. You don't want that, all right? But this is maybe you don't care about some spam coming in your inbox, and then you can delete it manually, right? So you need to think about this trade-off, and Power BI is going to give you the a way to put some monetary values to this to this cost and benefits analysis. I'm going to show you that. Let's go back to the Power BI to see if that finished. It looks like it's still running, but let's refresh it just to be sure. Okay, it's not running anymore, so it looks like it finished. Let's go there. All right, so it's here. So I'm going to click in View Training Report. Okay, and here it's going to take a while, maybe less than a minute, but what it's doing behind the scenes, Power BI is not only creating a report, it's going to create a data set and a report. That's the reason it's taking so long. It's going to create a data set that, of course, we can use it later also to create other reports based on this data, right? Okay, let's give a minute. It looks like it's coming. All right, it's up here. It's three reports, right? The model performance, accuracy report, and training details. Okay, let's talk about the first one. And here is the confusion matrix that I mentioned, I explained to you, and the slicer with the probability threshold. All right. So in here, the recall is 100%. It's 100%. Okay. But look at what happened. What happened when I decrease that and increase the precision. Okay. False negatives start to show up, right? Look, false negatives start to show up in here. Okay, and when I maximize the recall, okay, false positives start to show up, right? So again, what is the optimum value? Is 0.5? No, it's not 0.5. It depends of your use case, right? And here they have this nice way to choose this probability threshold. Is the cost benefit analysis that I'm going to put a dollar value to the benefit when our model is correct versus when our model is incorrect. Okay, let's say that when if we are doing a campaign, we're going to do a campaign, we're going to use this model to do a campaign and maybe send gift cards or some kind of do some kind of expense to reach these users, right? For each user that that I reach correctly, and I guess correctly that this user is going to purchase, I'm going to make 20, and it's going to cost me maybe let's say 6. Okay, okay, like you see, and we're going to do this for 1,000 users. Okay. The curve has modified depending on this. The curve is going to give us the profit, okay, which is the benefit minus the cost, and the probability threshold. And this, of course, I want to maximize this profit, right? You see, when the probability threshold is 0.2, it's about 0.23, the profit is maximized all the way to 0.61, right? And here is what this says in the text, right? Okay, the maximum profit is 0.23. Okay, so we can put this 0.23 in our probability threshold. So this is the optimum value that we're going to use for our model. Now, okay, let me apply the model. And now remember, I added this new data table. This is how we're going to use it. Okay, we're going to have this new data, and we're going to use with this threshold, right? We're going to use this. Let's call it new output column name. Call it predicted purpose. Okay, and let's save and apply. Okay, and so this is going to take a little bit also. Okay, let's wait. Let's go back to the slides here, to the slides, and to show you this. Okay, as I show you in the screen, this probability threshold that is showing here is the one that we're going to use. Okay, let me show you in Power BI. It's still running. Oh, doesn't want to show this. Let's wait. Okay. All right. Okay, it looks like it did it. All right, but let me finalize showing the other pieces of the report. Okay, the first report was the confusion matrix and the cost benefit analysis. Now let's take a look to the other tab, is the accuracy report, and it show us the area under the curve. The area under the curve determine how good is our model. If I training this model using different data, or maybe there is new features or new attributes that I included in a model and I run it again, I could compare different models with the ROC curve. If the model, the perfect model is going to try to go all the way to this corner. I'm going to try to occupy fully this square, right? This line is the random probability 0.5, right? So in here it says the model. The model is 95% accuracy, random guess 26%, false positive rate 52%. The true positive rate is compared versus the false positive rate. All right. So this gives us a way to compare different models. If we run another similar model, we can compare how good it is versus another model. Okay, and let's go to this next tab. Okay, and this next tab is going to show us some technical details about how our model work training. Even though we don't really need to know about these results. It's very important to understand the model performance accuracy report, but this piece is the one that Power BI is doing behind the scenes. Okay, and it gives us multiple iterations, and in each iteration is using the different algorithms and calculating a score. You can see in this case, it is getting a score of 97 using the light GBM classifier. Okay, another one is going a score of 0.98 with another light GM classifier. Okay, and most likely it's using different parameters for this one. Here again, the light GM classifier, random forest classifier, random forest extra trees classifier, and this one 99 with prefitted soft voting classifier, and this is the one that gives the best score. All right, so let's go to the bottom of here. There is a nice graphic here. It's going to show if the assembled model is the best for this in this training, right? What is the assembled model? Assembled model is a model that is being trained using multiple models and is getting vote techniques. Well, it's using multiple techniques, really, bagging or boosting. But at the end, the results of all these different classifiers are being average, weight average, or using majority vote to do the prediction. Okay, and you can see this. Actually, this this model in this case, it uses this assembled model, and it uses all these models, and it set all the parameters they use for each model, right? Okay, so let's go back to the report now. Let's go back to this data flow first. Let me show you really quick the product of the new dataset. The new dataset that I use and I apply the model is going to give us new fields now. All these fields, predicted purchase outcome, predicted purchase prediction score, and predicted purchase prediction explanation are being added by our model. And then I have this other data that is showing all the fields and the contribution of the fields predict uh, each of these labels. Okay, let me show you a report. Let me go here. Maybe I have a report with new data. Okay, let me show you this. Here you can see this is the data that was used, that was applied, that the model was applied, and it's the same information that we have, the same attributes, plus all these predicted output explanation are the fields, three fields that were uh, were added by your model. Okay, and basically what you can do, because this is in a data flow, you can use that and use your custom report, right? And you can see your custom report, and you can see for each record you can see an explanation of which fields, which values are the one that contribute the most to do this prediction. Okay, let me go back to the slides. Okay, I show you already this in the report, and I show you already this iteration, and I show you the assembled models also in the report. Okay, there is other, again, just to repeat the importance of the measure that you're going to use for your model in your use case. Depending on your use case, you might use different metrics, right? The accuracy is not, as we see, the accuracy is not the most important metric, right? Many times, like Power BI allows you, is a balance between the precision and the recall. There is other metrics like this one, for example, F1, that we can use in some cases. Okay, and at the end we have these pros and cons. As you see, there is a lot of pros uh, that is going to save us time, okay, to produce this. Okay, and anybody can do it, and you see there is no need of expertise in some steps. Some steps might need some specialized knowledge, uh, and the fact that when we will need to pick all these algorithms, that's going to be time consuming. Time consuming. Behind the scenes, Power BI also is going to normalize the information, scale the information, things that we didn't have the need to do it, right? Not, you have to do it manually with using Power Query, right? So the hyperparameter optimization, we don't have the need to do it. AutoML is doing this for us. Okay, and again, Power BI doesn't need an expert of knowledge in data science or machine learning to do this work. It generates great result in relative short time, easy visualization, quick tests, hypothesis around predicted value of data. Okay, that's nice. That's the pros. And the cons, the feature and model interpretability might be sacrificed to some level. Yeah, it's going to be difficult to interpret your model if you have this assemble and all these iterations. How you can debug the model, right? That's not part. AutoML is like a black box, right? It's in charge of that, and you cannot get there. Also, the human understand the data set, then builds features, while the machine build features first, and human try to understand them afterward. Yes, we have to understand the report, whatever is getting the results. Then we have to try to understand and play with those, right? Play with the trade-off with the slicers and get the best metric and the best probability threshold for our use case. AutoML sometimes is compute intensive, leading to relatively long execution time. That's true. What I show you in this demo is really a very simplified version, but when you are dealing with millions of records, that might take hours, right? And you might have to use a high capacity for this. Besides license codes, might also need infrastructure costs. Well, again, this is not free. Even though the Azure give you flexibility, you don't have to pay per month. You only have to pay per user. Model selection is limited. And here there is not enough documentation about AutoML in Power BI to see what models are using in this one for the iterations. But there is a report at the end that gives us the final results, right? Okay, so basically the recommendation for to use this AutoML, even in any platform, is to get a quick result, something like a prototype, prototype of a sample of your dataset. It will be okay. But when you want to start to dealing with big data, that is when you want to do to more powerful platform, right? Like Azure Databricks or Azure Machine Learning. Right, there is some links about this, the Power BI AutoML documentation. That will be it for the presentation. Any question? Right, just remember if you are paying by the usage, so if you leave it there, it's going to consume hours from your subscription. So just pause the services always, right? Not only for this service, for any server that you are using on demand, don't forget to stop it, right?
All right, great point here that Hector has outlined. I would just like to remind you, have a question, you have a last minute here, enter and use the live chat. If you have a question afterward, just remember to use the comment section. We'll follow up with the presenter. If the material presented here is of use and you enjoy it, remember to like, subscribe, and share the video here so we can continue here with the community. And if you are in the South Florida area, we are meeting in person. So check out our meetup for our next in person presentation right here at the Nova Southeastern University. All right, let me check the questions. Hey, Marco, thank you. Oh, there's a question here. Marco is asking, will the pause service re-enable back after a period of time or not?
Excuse me?
So the question is, will when you pause the service, does how can you re-enable back after the period of time or not?
Yes. Once you just pausing the services, you don't destroy. You can delete it if you don't need it, but you want to, if you need the reports and the data flows created, yeah, you just uh, start it again. Okay. A good idea would be to have this automated, maybe with a PowerShell script, and have some kind of service. If you are doing this every week or every month, you can even automate this and have a machine learning service just opening and refreshing your information, refreshing uh, all the new data, the incoming data, right? And put the incoming data in another place, another data set to be consumed without the need to have this service running all the time, right? But of course, yeah, we can start the service again and have it and have it running, right?
Excellent. So thank you for explaining here, Hector, how we work and what happens with the pause, as well as if your user wants to have it running on a regular basis and everything. All right, folks. Any more questions there? Thank you very much for the question there, Marco. Yep. All right, Marco liked the answer there. Thank you. So just one more minute here, folks. See if there is any question regarding the presentation. And in the meantime, I remind you, we are here in the South Florida area. We are at Nova Southeastern University, which is at the Navy campus in Fort Lauderdale. We'll be meeting here on a regular basis with the South Florida Power BI, as well as the Power BI to them, as well as with the Microsoft Data and the AI South Florida user group. So stay tuned to upcoming presentations. Remember to like, share, and subscribe to the YouTube video and to join our meetup. And that information, you can just check the description, the video description below, and you can see our meetup information about our presenter Hector here. All right. All right. Hey, thank you as well, Marco. And I don't see any more questions, so we'll bring this presentation to an end here. Thank you all for being here, supporting, and making the time to learn here with the South Florida Power BI user group, as well as thank you very much, Hector, for being here in person with us and sharing the knowledge.
Yeah, no, thank you to you for inviting me.
We look forward to have you here in future presentations. Appreciate it.
Okay, great. Thank you everyone.